Well guys, on the bench we have another golden nugget of Bantam history, introducing the D10A engine. And we have to talk a bit of Bantamology to understand the importance of that. The D10 was another stopgap model, 1 year only, 1967. It sat between the D7 and the D14 and later B175 models, which were the last of the line. Initially, or certainly in the range, the D10 had a 3-speed Bantam Super, which looked very much like my D7, but they also did a sports version which looked like a cafe racer, I think intended to get the young'uns back from Honda. I'm not entirely sure how successful they were, but I think they did sell quite well. And they also had the Bushman, which was the on-off-road trail version. Again, an attractive bike, and I think they sold reasonably well. But the Sport and the Bushman had the D10A engine, and that was a 4-speeder. So what we have here is the first of the Bantam 4-speeders. So yeah, this was something that I was hoping to find, and quite happily I found this one. So this being a stopgap and the D5 frame, or the D5 model being a stopgap, I've decided to christen this project the Stopgap Special. So that's what we're going to call it. This engine is, well, it looks reasonably good, but I know it does have some issues, has some challenges. It isn't all there, so it should get on quite well with me. And there are, you know, 1 or 2 bits missing and a few bits of damage that we're going to have to deal with. I know for a fact it doesn't have a piston, and I know this because it's fitted with the optional inspection cylinder head. A very innovative product. I don't think it was such a great idea. I imagine loss of compression and the exhaust makers going on strike because they thought they were redundant. Probably, you know, not such a great thing. But yeah, definitely doesn't have a piston. Side covers are loose. I can see a rotor in there, but we've got no stator. Not a great issue because, you know, we'll probably go electronic like we did with the D7. And I haven't had the clutch cover off, so I don't know if there's any bits missing in there. But what I thought we'd do is have a bit of a sneak peek, take a few bits off, do some measuring, and just kind of get a feel for what we've got. I don't want to split anything. I don't want to split the cases at the moment because I'm not ready to have this thing dissected all over the place. We're still working the D7. So let me get some tools and we'll have a bit of a scoot around it, and we'll see what we've actually got. Right, I've got some tools, so let's get into it and see what we can find. We know we're not going to find a piston, but we'll see what else we can find. We've got 1 cylinder head stud fitted, or partially fitted. The nut's not all the way down. It looks rather rusty and crusty. I don't know how easy it's going to be to get out. We'll give it a go. Oh, spoke too soon. It's hand tight. Actually appears to be just going round and around, so that's possibly a red flag, I think. What pliers have I got? I've just got my electrical pliers, they'll do, I think. Yeah. Well, that came out all too easily. There's threads on the stud. Let's take the head off. One cylinder head, which looks, where's my scriber? Excuse me. Which looks like it's been out in the weather. We've got some quite heavy pitting here, and some here as well. Combustion chamber surface is quite corroded, but doesn't appear to be any of it missing. You'll notice there's a squish band here. That's a D10 thing. They actually squeezed an extra couple of brake horsepower out of the D10s. The D7s were, I think, 8 horsepower, or 7 perhaps, and the D10s were 10 horsepower. And they used a dome top piston. Excuse me, losing my voice. Dome top piston, and they squish banded it. And they also raised the compression ratio. And they did that by the combustion chamber shape, the piston, and they used stuffing plates on the crankshaft, which is a hark back to the earlier Bantam models, because they used stuffing plates as well. The D7 didn't have them. And yeah, so hopefully when we get into the engine we'll find stuffing plates on the crankshaft, and then we'll know it's a genuine D10 excuse me, a genuine D10 crank. But we certainly seem to have a D10 cylinder head anyway. So we'll put that out of the way. Have a look inside our barrel. I'll get you moved a bit further up so that you can see what's going on. There we go. So you're looking down the barrel. We have a crankshaft at least, so that's good news. Usually, if there's going to be fin damage, it's the top fin that's broken, and this one's. Oh, I thought that was a crack. It's not. It's just some sort of dirt. Yeah, there might be a crack there actually. There might be a crack there, right there. You probably can't see it on this camera, but you get some light on there. Yeah, I think there's a crack there. And if I'm not mistaken, that looks a bit like a blob of weld there that's been used to stop the crack. But they haven't stock drilled it back here, so it's free to roam wherever it wants to. So we'll have to do something about that, I think. Otherwise we'll end up with a similar situation as the D7, where we end up with a chunk of cylinder fin breaking off. We don't want that. So that's the first thing on the list. I'm going to make a note of these things as we go along, I think. Otherwise I'll forget. So top fin crack, question mark. I don't think it's much of a question mark, but we'll do some more digging, find out for sure. Okay, I'm going to move the camera again slightly so we can have a bit better look at the barrel. I'm already seeing some potential horror stories on the crankcase face there. The reason why we only had one cylinder head stud, and the reason why it was such a terrible fit. So this is our barrel. It's a little bit rusty. We'll do some measuring later on, I think, find out what size we're at. But it's definitely a D10 barrel. You can tell that by the porting. So if you can see very well down there, much larger exhaust port than the D7 to match the larger, what they call the big bore exhaust. And then we've got a partially bridged inlet, and also larger transfers. And we should have a dowel hole as well, which we do here. The D10s had a dowel between the cylinder barrel and the crankcase, and I think that was just a means of making sure that the right motors went together in a factory where they were building probably, you know, more than one type of engine, but I'm not entirely sure. I may be talking out of my you-know-what. But anyway, the D10s definitely had the dowelled barrel. So let me move you back in, and let's have a look at this new and interesting horror story. I'm just going to zoom you in a little bit, just bear with me. Right, I've got you zoomed in a little bit, and well, look at this. We have some nastiness. Where's that stud? So, stud holes that can best be described as enormous, 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 and, well, it threads in, but you wouldn't want to use it. Fantastic. So someone has drilled these out at some point and tapped them oversize, and I think they did it in the dark. Yeah, huge ovality in that one, huge ovality in this one, same here. This one looks round, but the threads are very worn. The dowel hole looks very oval as well. Is there anything stuck in it? No, there appears to be no dowel broken off in there. So how that's got oval, I don't know. Oh dear, I've seen something else as well. Yeah, there's a hole in there. There's an awful lot of drilling swarf as well, but there is a hole. Let me just oh my goodness, yeah. There is a hole approximately 8mm high by possibly 6 or 7mm wide. You could probably see the light coming through on the torch. Yeah, you can. And in fact, I've got the scriber in my hand. Let me just see if you can see that on the camera. Can you see the scriber in the hole? I'll do the other end actually. Check that out, people. So they've broken right through to the outside world when they've drilled it out. So that's a bit of a disappointment, isn't it? Have to have a bit of a think. D10 cases are not particularly, what's the word I'm looking for? Not particularly prevalent. They do come up from time to time, but they tend to be rather expensive, and yeah, I think we definitely need to have a think about how we can repair that. So I'm going to have a bit of a think while we carry on looking at the engine. Crankshaft. It appears to be an original rod. Doesn't look like an aftermarket rod to me. Yeah, there are some numbers on the side. 91 something something. If it begins with 90, it's a genuine BSA number. It looks as though someone's ground the side of the rod. There's grinder marks on it, which is unusual. Let's have a feel of the big end. The crank looks very clean, but the rod is definitely not an aftermarket job. There's no movement at all in the big end, none. So I wonder if someone's had that apart and changed the rollers rather than do a rod kit. Potentially. A little bit of side to side, but not much. Not much at all. And I'm just looking for the stuffing plates, and I can see them. Well, I can see this one anyway on this side, but it looks as though they've been welded on. Now they should be riveted on, but what used to happen was the rivets would come undone and completely destroy the bottom end of the engine, and they were very difficult to put rivets back in once they come loose. So I'm thinking that someone has welded them up. It looks a reasonably tidy job actually. Let's have a look at this side. Can't see any welding. Oh yes, there is. Yes, so we've got welded stuffing plates. We've got a rod that doesn't appear to have any adverse play in it. So perhaps someone's had a go at rebuilding this crank. I think that must be the case. And the grind marks on the side of the rod, I can only imagine, I don't know. So someone's tried to grind the number off it, but why you would do that, I don't know. Anyway, there is a small end roller bearing. It does move, but it doesn't feel fantastic, but it does move. But we can change that, not a problem. So we may have a crank that we can use if someone's done a reasonable job of rebuilding it. We may have a crank that we can use, which is good. Obviously, we'll have to check the truth and you know, make sure there's no damage to the journals or anything like that. There's quite a lot of oil on it. You can probably see that. Ew. Well, it looks like oil, and it feels like oil, and it smells like cat pee. So you tell me what looks like oil, feels like oil, and smells like cat pee. I don't know. Oily cat pee? Who knows? I don't know. But anyway, that's what it appears to be. But yeah, the crank does look pretty clean, so let's keep our fingers crossed that we've got a usable unit there. Right, I shall move you again and we'll have a look at another part of the engine. Okay, I've got you moved, you're on the tripod, and we're going to have a look at what's underneath the side covers and see what we've got. Let's just take that out. Oh, we should have a dipstick on there, but someone's cut that down. See how it's been hacksawed off potentially, or angle ground. So that's not ideal. Clearly what happens when you buy a sight unseen second-hand engine. Now I'm turning it over because what I want to see is if there are any casing numbers, to see if we've got a pair of matched casings. Are you seeing that? You are. So we should have a number. It's usually just under the under the crankcase here. Nothing there. Oh, here we go. S303. S303. So possibly the first bit of good news we've had so far, matching crankcases. It's not an issue if you don't have matching crankcases. You just need to make sure that the lay shaft bearings are line reamed, because they're done as a pair at the factory. We've got a bit of a break there to the casing, piece missing, which bears all the hallmarks of a broken chain. There's not many Bantams out there that don't have damage to the casings around where the chain fits, because if the chain gets too loose and sloppy or it breaks, it has a nasty habit of biting a lump out of the casing. So what can you see? Let me just move you back a little bit. There we go. So let's take off the mag side and see what we can find. Fingers crossed, eh? Bit of a dent there. Looks like the brake lever's hit it at some point in its life, so accident damage, I would say. It doesn't appear to be. Hang on a minute. Let's not let's not jump to conclusions. It doesn't appear to be cracked, but there is a mark on the inside, so it possibly is. So I'll get that out of the way. Then we should have some nuts holding this on, which we haven't, because we haven't got the stator fitted. There's usually a 2BA screw in here. Oh, make sure you're seeing everything. So there's normally a 2BA screw in here, but that's missing. So we can just take the casing off. We have a clutch mechanism. Which works. But we don't have the adjuster screw and lock nut. And I imagine we probably don't have a push rod in there either. So we've got the later Y-pack rotor, but no stator. But I don't think that's an issue because we won't be using this anyway. And it looks as though somebody has changed the mag side oil seal. So that looks like an absolutely brand new seal. So somebody has been going through this engine, but not particularly well. The seal here on the output shaft, on the main shaft, that looks as though it's brand new as well. What's the thread like? Feels decent. And the seal carrier is part of the casting. On the D7, there's 3 screws that hold an assembly on here, and that's how you can. Another way you can tell that it's a 4-speeder is because it doesn't have the screw-on seal carrier. And you'll notice here, look, this is the back end of the lay shaft bush. And I don't know if you can see that, but it looks as though the chain's been running against it, because there's quite a good bit of metal missing there. Quite a bit of wear where the chain's been fretting against the casing. And then we've also got a telltale little bit missing here, which is usual. Sometimes this whole piece of the casting breaks out because the chain breaks and smashes through here, but we've lost a bit there, and we've lost a bit here that we could see from underneath. So I think it's had a broken chain at some point in its life. So that is the mag side dealt with. You see all the new cap head screws. So someone's definitely been trying to rebuild this engine. And I'm thinking that the head studs, the threads here, it's probably what stopped them and caused them to abandon it. And now I've got it as a problem. So we're not going to abandon it. We're going to find a way. So, clutch side. Let me just check your view. I want you to see as much as possible. There we go. Someone's been shining it up. It just shows you what people's priorities are, doesn't it? Polish the casings, but you know, there's no threads in the crankcase mouth. What are we seeing? So we've got 2 screws in, and that's all. And we've got some damage here. It looks like the kickstarter's been rubbing against the casing. So behind here is where the points plate lives. On the D10 it's different, and the B14 and the B175 to the D7. On the D7 the points is with the mag on the other side. On the D10 the points are on this side in a separate housing, and the cam is on this end of the crankshaft, the points cam. So let's take this off and see what we've got. If we can get this off. Yep. Completely rounded. And I think it might be bent. So yeah, it is. It's going around like a camshaft. It doesn't appear to be threading out either, so that does not bode well. Let's put some pressure on it. The trusty snap-on Blue Point electrical pliers have won the day. Oh, yeah. Slightly wonky. Points cover. Points cover looks okay. But no points plate. Missing. Again, not a great issue because we probably wouldn't be reusing it anyway. Let's have a look at the end of the crankshaft. They split. Usually when people are manhandling the crank, these cone-shaped ends here can split, and when that happens, because there's a thread at the middle, you struggle to get the points cam to tighten up onto the taper. The screw won't thread in, because when it cracks, it expands the hole. And that wouldn't be an issue for us, as we're probably going to go electronic, but I think the fact that the crankshaft is in good condition at the end there might be an indication that someone's at least taken a little bit of care with it. Possibly. We'll see. Right, let's get the clutch cover off. So they didn't go to the trouble and expense of fitting cap head screws to the clutch cover. Maybe that was next on the list when they either realised that the threads in the crankcase mouth were knackered, or they knackered them. I probably should have checked that there was no oil in it, but it's only got 2 screws holding it on, so let's hope not. I think probably not, but we'll take our chances. Famous last words. Just make sure the Kickstarter spring doesn't fire off and do something crazy. Incomplete. I think appears to be the theme, doesn't it? So we've got a clutch drum or basket, if you prefer. We've got a primary sprocket, and we've got no clutch pack. lot of play in the clutch drum bush. The gearbox appears to be turning over alright. At least the main shaft does. The bearings feel okay. We've got a Kickstarter shaft and spring. Yeah, that feels alright. Good splines on our Kickstarter shaft, and fairly good splines on our gear shift shaft. Obviously no primary chain, we can see that, and it looks reasonably clean in there. Can't feel any movement on the bearings. And the crank turns over quite smoothly. So it appears that someone's done a bit of work to the crank. They've been working through the engine, possibly rebuilt the gearbox, we're not sure, we don't know. Certainly haven't finished working on the clutch because we've got play there and we've got no clutch pack. And then something perhaps has happened to these threads. They've realised that they couldn't fix it and they've abandoned it. The oil seal in the points, where the points go, looks like it's an old one. Doesn't look particularly new. We've got telltale signs here and here, where the clutch basket, let's move it out so you can see it and get it in context, where the clutch basket has been rubbing against the clutch cover because of excessive end float. And then, oh dear, to coincide with the damage caused by the Kickstarter chewing the casing, or perhaps it got impacted into the casing, we have a corresponding bit of damage inside. It looks like the casing's cracked. So, rather poor show. Rather poor show. But, ever onward. We are a motorcycle restoration channel, so we've got something to restore. We've got some work to do, definitely. We've got some challenges. Rather more than I anticipated, but that's life. We've got a D10 engine with matching cases, potentially good crank, potentially good gearbox, potentially good barrel, reasonable looking head. So it's a starting point. And for what I paid, I think, you know, we should be able to do something with it. So before we get on to measuring up the barrel and seeing what sort of bore size we've got, let's have a think about these rather dodgy threads. Let's have a think about how we might be able to fix them. And I'm just going to move you again. Right, we're back, and it's a bit of a time lapse. I've had about 25 minutes, half an hour thinking about this since I last spoke to you. And I've been doing a little bit of research, and I know that the threads are supposed to be 5/16 Whitworth, and clearly they're not. So I looked up the helicoil size for a 5/16 Whitworth, and the drill size rather, and it's 8.3. I don't have an 8.3 drill bit. I do have an 8, and it drops in like a thing that drops into something. Almost goes into that one. Almost goes into that one, but not quite. And obviously we know that one's not too far off. I also have an 8.5. And I'm not entirely convinced that an 8.5 would clean that up. It might clean that one up, but we've got the added bonus of a hole right through to the outside world on this one. It might just clean that one up, and obviously with that one we know that it would, because that one is not too far off. But 8.5 is no good because we'd need to be 8.3. So we also have what possibly is nothing, but is also possibly the beginning of a crack developing from the edge of this hole here. We've certainly got a stress razor, a sharp edge, so we really want to get rid of that as well. I thought this one was holed at first, but it isn't. But there is a void in there. Oh, sorry, you can't see for my hands, can you? There is a void in there. The hole kind of widens out part way down, so there's a void. So that's a problem. So I think the only way to recover this would be to get these, well, obviously get the crankcase halves split, cleaned to within an inch of their lives, and then weld up these holes. Just completely weld them up. Weld the hole in the casing here. Weld these up either by drilling them out and fitting plugs, or just welding them. And I'll take advice on that. I have a couple of people that I can go to. One of whom is my brother, Carl Wilson. If you haven't watched Carl's channel, which is called Carl Wilson, go and give it a watch. He's a very clever engineer. Yeah, I would take advice on whether to sort of drill these out a bit more and put plugs in and weld them in. Although we're losing quite a lot of wall thickness there already. It's quite thin. Or just plug weld the damn things up. Machine this surface back to, standard where it is now, and then just redatum the whole thing. I'd probably weld up the dowel hole as well, and then we could put the barrel back on. Where's the light? There it is. We could line up the transfer ports so that we know we've got the barrel in exactly the right position, and then we would make a transfer punch that was an excellent fit in the stud holes, immobilize the barrel, and then transfer punch the new datums. Pick up the centers on the VMC, drill and tap, and then potentially just go straight for helicoils, because I think in aluminium it's a good idea to put helicoils in anyway, but we wouldn't necessarily have to do that because we would have fresh metal with brand new 5/16 Whitworth coarse threads for our new head studs. So that might be the way to recover this. And then we could make a transfer punch for the dowel hole on the barrel. Hang on, let me get you into position. Make a transfer punch that just fits in there, because that doesn't look like a bad hole in the casting there. And then once we've got our new studs in position, we could lower our barrel over, give it a tap, and then pick up and re-drill our dowel hole with our transfer punch mark. So quite a bit of work, but I think it could be quite interesting to recover these crankcases rather than give up on them and try and spend more money and get new crankcases. I think bringing these things back to life might be quite an interesting little project. So that's my thoughts. The rest of the damage that we found, mostly limited to missing parts or just general wear and tear, which is what you're going to find in a second-hand engine that's had a life. And then obviously we've got our crack in here, which could potentially be a bit more welding. So I guess I better practice AC TIG welding, because I don't want to make a mess of it, and I want to do a good job. But as I said, there's plenty of advice available, so I'm not going to be alone in the task. I'm fairly sure of that. So that, I think, is it for the crankcases. I'll just do a bit of measuring on the barrel, and we'll see where we are for a rebore, whether we need one or not. I think we probably do, judging by the rust in there. Certainly a hone, but we'll see what size we're at, and then I think we're probably done for looking at this engine. It's going to be a while before I get onto it, because we're still working the D7, but at least we've got an idea of what we're up against. Right, we're just going to do a bit of rough and ready measuring. I've given it a bit of a wipe out with some methylated spirits. It isn't looking terrible. There's a bit of rust in there, but there's no deep scoring or anything like that. So we'll see. What's it like at the top here? There's a little bit of a ridge actually. Feels fairly even. Can't really feel it with these gloves on, but this engine's a bit manky, hence why I'm wearing the gloves. That oil on the crankshaft, I don't think I'm going to be getting that all of my hands, but there you go. Just do a rough and ready measure just to see where we are. I'm just going to do it with the digital caliper for now. We're just getting a rough idea of how far away from standard we are. Standard is 61.5. So I'm getting 62.3. So we're oversized, aren't we? Let's just do a couple more. Now, the pistons that you can get for these are generally 40 thousandths over, and 60 over. And I think 40 over is 62.5, and then plus clearance, obviously, because the clearances on these are quite generous, generally about almost 4 thou, I think, which sounds like a lot. I think it's 3 9/10 is the clearance for an oversized piston. Yeah, 62.3 or 62.28 I'm getting there. So let me just go and do a bit of quick maths, but I think it's 30 over plus clearance. Right, so I'm hoping that the pencil has got enough contrast and you can see my working out. I suspected it was a 30 thou rebore, and I think I've proved that it is now. And this is how I did it. 30 thou converted to metric is 0.762 millimeters. That would give us a rebore size of 62.262 if we didn't have any clearance, if we didn't add any clearance. The clearance for an oversized piston is about just under 4 thou, so about 3 9/10, which comes out at 0.099 millimeters. So if we add our clearance to our rebore size, we get 62.361. And my rough and ready measuring with the snap gauge and digital caliper was given us 62.3. So that's pretty much in the ballpark of a 30 thou rebore. So let's have a think about what we can do with that information. So we know we've got a 30 thou rebore. If we could find a 30 thou piston, we might get away with just honing this. If that sort of light surface corrosion would come out with a hone, I think it probably would. And we'd probably get a run out of it, and that would save an oversize on our barrel. However, you can't get 30 thou pistons brand new anymore. Certainly not from any of the sources I know of anyway. You can get a 40, you can get a 60. So that kind of puts us back at the pitch situation where we need to rebore to 40 and fit a 40 thou piston. And then we've still got another rebore size after that to take it to 60. We could look for second-hand piston or a new old stock 30 thou. I might have a bit of a, put the feelers out to a few of the BSA parts people that I've dealt with in the past and see if there's anything out there, but I'm not going to hang my hopes on it. Chances are we're going to end up with a 40 thou rebore and a new piston. So that's where we are. That's as much as I'm going to do with this engine at the moment. I'm going to basically loosely reassemble it, put it in a box, and batter on with the D7. I've had some metal come in, so we're going to have a look at the exhaust joining pipe so that we can get that finished off. And yeah, I'm going to basically turn my attention back to the D7 and see if we can get that bike into running and riding condition. But this has been instructive to me. I now know at least what I've got. I hope you've enjoyed watching me go through this engine. Obviously we've got a lot more to learn about it when we split the crankcase halves. We get into the gearbox, we have a look at the crankshaft. There's more to discover, quite possibly more bad news, we don't know. It could be good news, we'll see. But I've at least got a baseline on this engine, and as I say, I hope you've enjoyed it. Thanks very much indeed for watching. Thanks to all my subscribers. Yeah, the channel is growing, and I really appreciate it. If you're not subscribed, please do. It's all grist to the mill, and it helps us out. So I shall see you soon.